Hey guys, section 8.2 we're going to do today, tonight. So what we're going to do today is graph simple rational functions. Meaning, what is a rational function? What does rational mean? Rational means can be expressed as a fraction. So basically I'm going to give you a function that is a fraction. So you know linear functions, quadratic, so on and so on. Here's what a rational function is. So rational, oops, supposed to be one word, function. Basically it's this: f of x equals a fraction, so something over something else. So what they say in the book is p of x divided by q of x. Some function divided by another function makes it rational, can be expressed as a fraction. So example, f of x equals whatever you want, 5 divided by x. This is a rational function because it's a fraction here. Okay? So what we're going to learn about this is how to find domain, how to find range, how to graph these things, and what those graphs look like. Now, with these graphs, they're not nice. If you type this in your calculator, it looks weird. Alright? So it'll actually look like this. Something like this. Okay? Now what do you notice? If you look at it, there is what we call asymptotes. Remember those? Asymptote is basically a line that the graph will get closer and closer to, but never touch. Well, maybe not never, but 99% of the time. Look at this graph. This graph gets closer and closer to, should have drawn it a little bit better, but closer and closer to the x-axis, right? What is this x-axis? What is that equation of it? Y equals 0. So the x-axis is an asymptote. Notice even this thing here. By the way, this thing is called, notice this thing and this thing. This rational functions isn't like one continuous thing, like a line. It's continuous. For this, I have to pick up my pencil. I draw this branch. We call this a branch, and then I draw this branch. Okay. So every rational function, just about every one, has asymptotes. So you'll be dealing a lot with that. Okay. Now, the first asymptote is I drew here, horizontal asymptote. It's this one. Notice the graph never touches this. What else? What else does the graph never touch? Notice how I drew this. It's never going to touch this one, which is, what is this line right here? It's a vertical line, and it's at 0, so this line is x equals 0 is a, what type of asymptote is this? Well, it's going straight up and down, so we call this a vertical. Why isn't this showing up too well? I'm not sure. Asymptote. Okay, so what you're gonna find is, especially in the later section, it gets harder, but you're gonna find all the vertical asymptotes, which is just this one for now. And you're gonna find all the horizontal asymptotes. Where doesn't it cross horizontally? Just right here. So that's all you need to know for this rational function. We call these simple rational functions. Yes, and they're named that. So the next section we get into general or more complex rational functions. Okay, we're going to stick with these easy ones for today. So lucky you. So here we go. Any rational function I give you today is going to be a simple one. So let's start out. Section 2, simple rational functions. Here I got this from your book. Maybe give a little bit more insight here. The graph of the parent is y equals 1 over x, which looks like this. Notice the two branches. Okay, vertical asymptote is the y-axis, which is x equals 0. Horizontal, the x-axis, which is y equals 0. Those are your two asymptotes. Notice it says it's called a hyperbola, which is two symmetrical branches. I told you. Here's a branch. Here's a branch. The domain and range are all non-zero real numbers. Meaning, look at this right here. What can't x be? X can't be 0. Could it be negative? Yes. Could it be positive? Yes. It can't be 0. So the domain is all real, everything except 0. So that's why they say non-zero real numbers. Even the range. Here's how I do the range. I look up and down, right? Range is y value. So it keeps on going up and it keeps on going down. But what doesn't it ever touch? It never touches this thing right here. So basically your range is all real numbers except 0 as well. So range, I'm just going to put that tick mark there. All real except 0. So there you go. So now how to find domain, range of these functions. Now this should say g of x equals a over x if a can't be 0. So a can't be 0. It can be anything else. Okay? But they all have the same asymptotes. This one and this one. They'll have the same domain. This, they'll have the same range. So that's why they're called simple. That's all the same. So let's look at example type number 1. Graph the function y equals 6 divided by x. Compare it with this one. So type this in your calculator, type this in your calculator, and you're going to see a difference, but they're similar. Okay? So this is y equals a over x. Actually, that's right here. Okay? So what's the difference between 1 over x and 6 over x? Well, let's look at the graph. Okay? The graph is here. Notice the blue. The blue is the normal 1 over x. Okay, there's the parent. There's the parent right there. Okay, notice the red. That's y equals 6 over x. Notice the branch is farther out, right? 1 over x is very close to the x-axis and y-axis. 6 over x is farther out here, but it still gets closer and closer to the x and the y-axis. So it'll still get closer and closer. The asymptotes, notice, are still the same. X equals 0, y equals 0. So you draw your asymptotes, maybe a dotted line to show me that you know it never touches. It'll never touch those. Okay? Alright, so you go to your calculator, you get some points from your calculator, you plot them. Here's one, draw the branch. Here's one, draw the branch. Okay? So, let's see. So draw the branches so they approach the asymptotes. And this just says, it says compare, so it says this graph lies farther from the axes, farther from the x and the y axis than the parent. So both graphs. So here's one thing. So is it farther away or closer? So here's some keywords. This is farther from the axes. The next point you have to tell me, where do the graphs lie? Where do the branches lie? I didn't say that yet, but every one of these so far had a branch here and it had a branch here. That's not always true. The branches are here if A is positive. Okay? What if A was negative? Alright, let's go do one. If you type that in your calculator, like y equals negative 3 divided by x, you're not going to get a branch here, you're not going to get a branch here. They're going to flip. Okay? It's a reflection. So now you're going to get a branch here, and you're going to get a branch here, something like this. And that's a rough draft, obviously, but that's what happens when A is negative. You want to write that down. If A is negative, then your branches become in the, let's see, this is the second quadrant and the fourth quadrant. But if A is positive, then your branch will be here and here. Okay? So, that's it. And then you might want to draw your axis symmetry here. So draw me like a dotted line and draw me a dotted line. It'll never, oops, that's sloppy. It'll never touch these right here. So, axis of symmetry. What about your domain and range? Your domain, all you have to do is look at this. What can't x be? X can't be 0, that's it. So you're going to say all real except 0. Your range, I don't know why this turns out so sloppy, is the same as above, all real except 0. So because it goes up and it goes down, but it'll never cross right here, which is 0. So there's some simple rational functions for you.